Introduction to Kappa statistic. What is Kappa statistic? The Kappa statistic was introduced by Jacob in 1960. The Kappa statistic is commonly used to test inter-rate reliability. For example, Kappa statistic measures how two radiologists agree on diagnosis, disease normal from same images. This is the definition for Kappa statistic. If you pay attention to the formula, there are two components, which are observed agreement and expected agreement. Unlike simple agreement, Kappa accounts for agreement purely by chance, measured by expected agreement. PO in red is the notation for observed agreement. PE in blue is notation for expected agreement. Read the reference for more information on Kappa. Characteristics of Kappa statistic. Let's focus on the denominator of Kappa formula. Expected agreement PE cannot be 1. Otherwise, Kappa will be undefined. PE ranges between 0 and 1. Therefore, 1 minus expected agreement is always positive. If PO smaller than PE, which means observed agreement is worse than expected agreement, the Kappa will be negative. If PO equal to PE, which means observed agreement is the same as expected agreement, the Kappa will be 0. PO larger than PE, which means observed agreement is larger than expected agreement. The Kappa will be positive. Special cases. Suppose expected agreement equal to 50% or 0.5. If PO equal to 0, which means no agreement at all, Kappa will be negative 1. If PO equal to 0.5, which means observed agreement is the same as expected agreement, the Kappa will be 0. If PO equal to 1, which means completely agreeing, the Kappa will be positive 1. If PO is between 0 and 0.5, the Kappa will be negative and between -1 and 0. If PO is between 0.5 and 1, the Kappa will be positive and between 0 and 1. Summary. Kappa statistic can theoretically be negative or positive and range from -1 to positive 1. Typically, observed agreement larger than expected agreement. Kappa statistics are between 0 and 1. Underlying mathematics of Kappa statistic. Observed agreement. Suppose a total of 100 images were evaluated by two radiologists independently. 35 images were evaluated as disease and 45 images were evaluated as normal by both radiologists. However, 15 images were evaluated as disease by radiologist A, but were evaluated as normal by radiologist B. 5 images were evaluated as normal by radiologist A, but were evaluated as disease by radiologist B. Observed agreement on being evaluated as disease equal to 35 divided by 100 equal to 0.35. Observed agreement on being evaluated as normal equal to 45 divided by 100 equal to 0.45. Observed agreement on being evaluated as disease and normal equal to 0.35 plus 0.45 equal to 0.8. Expected agreement. Expected agreement on being evaluated as disease. Probability of being evaluated as disease by radiologist A equal to 35 plus 15 divided by 100 equal to 0.5. Probability of being evaluated as disease by radiologist B equal to 35 plus 5 divided by 100 equal to 0.4. If two radiologists independently evaluate same images, expected agreement on being evaluated as disease equal to 0.5 times 0.4 equal to 0.2. Expected agreement on being evaluated as normal. Probability of being evaluated as normal by radiologist A equal to 5 plus 45 divided by 100 equal to 0.5. Probability of being evaluated as normal by radiologist B equal to 15 plus 45 divided by 100 equal to 0.6. If two radiologists independently evaluate the same images, expected agreement on being evaluated as normal equal to 0.5 times 0.6 equal to 0.3. Expected agreement on being evaluated as disease and normal equal to 0.2 plus 0.3 equal to 0.5. Kappa statistic. We have calculated observed agreement and expected agreement. We have the Kappa formula. We simply just plug in the values to calculate Kappa statistic. Kappa statistic equal to 0.6. This is the end of this video. See you next one.